Hello, welcome to 3D Solutions Spotlight here at Hawkridge Systems. Today's topic is going to be designed to print with SolidWorks and HP Jet Fusion 3D printing. My name is Holly Cheek. I'm the technical marketing engineer located in our Costa Mesa office, and I'm joined with Luke Davis, our 3D printing product manager located in our Santa Clara digital manufacturing lab.
Good morning, everyone.
All right, so let's start talking about kind of our story and what we're going to be going over. Here at Hawkridge Systems, we went ahead and decided to get a recording studio where we're going to feature different products where we actually interview the product managers and our specialists in a live camera room and then create video footage over it. In doing this, we've done a couple test runs already, and I work with the product managers here a lot and some of our employees, and some people tend to get more camera shy than others. So we've decided to come up with getting a teleprompter. That way they can look more into the camera. A lot of the times when someone's in front of a camera, they look down or they will look up or look to the left, and we really want them to focus on that camera. And to help gather their thoughts, we've decided that a teleprompter is a good way to go. So we're able to mount something just on the tripod to the camera in between there and have it extend out past. Here's an existing one that I can purchase online, but I decided that we have 3D printing here at Hawkridge Systems as well. So I should be able to design something just for the needs that I have at Hawkridge Systems for an iPad teleprompter. So I went ahead and I called our 3D printing expert, Luke, for some advice. I've never actually designed to print before. I come from a machining background where I was working more in CamWorks, not on printers. So Luke, I'm going to pass this on over to you. Well, first, let's talk about my design constraints. So I knew that I had my camera. I had the mount on the camera and the distance of the mount. I had the distance from the mount to the lens of the camera, and I had the iPad that I knew needed to be on this. So I needed a platform to the right-hand side of this. I also have the mount here on the right-hand side, showing that I need specific hardware to match up. So I need to design this mount into my teleprompter. So I showed this all to Luke, and he was able to help me out and give me some insight before I went in and started my design.
Yeah, so when talking to Holly, what I decided is I wanted to print an end-use part, and what technology I wanted to use was the HP Jet Fusion 4200 printer. And the reason is this prints end-use parts. Before, with a lot of 3D printers, they were more for prototyping. Um, they would degrade over time, or they were weak, or they just weren't accurate enough. So with this new technology, it's great. You print it, you prototype, and you can go into production with the same printer and the same part. What we're looking at here is actually the whole solution for the HP printer. So it's a printer. Also, you'll have two of these build units. So you can have one of the build units in the printer printing, while you have another one in the post-processing unit. And what the post-processing unit does is, one, you can recycle all the powder out of your build that's unused, and you can recycle it. In the post-processing unit, it'll take all that powder, put it in the drum off to the side, and you can reuse that for the next build. So your next build, when you put the post-processing, or when you put the build unit in it, you can repack it with 85% recycled material and only 15% new material, and that dramatically drops the price of printing. So let's go to the next slide here. So here's it in our office, and you can see we had just finished a print here, and this is a big production unit, but it's really nice, it's reliable, it prints really fast. Holly's part took about 3 hours of print time. The other thing that HP has done is they actually have built best practices so that you can read all the best practices and you can design around what the printer can do so that you get better prints faster, less having to reprint something. And one of the first things to know is how accurate this printer is. And it's about 0.2% accuracy. So if you have something that's 100 millimeters, it may be plus or minus 0.2 of a millimeter. So that's easy to design around once you know that limitation. Another thing to know is if you're engraving or embossing any type of lettering, How small or how big do you need to do this? And with the HP, it's about 1 millimeter either way. The other thing that's very, very important is wall thickness. Is it an unsupported wall or is it a supported wall? How much weight does it need to support? And how thin can you go? So if it's unsupported, I recommend it to Holly. Do not make anything under zero point 0.5 of a millimeter. And then once we print that first prototype, then we can adjust it from there. And then if it is a supporting wall, we'll make it thicker too as needed. Something to keep in mind with prototyping is you never get anything right first try. So you got to be willing to print once, look at what you did wrong, and then print another. With 3D printing, it's not about getting something perfect. It's about finding your mistakes fast, making changes, and then carrying on. The other thing with HP is you can actually print assemblies. So you can have like this green part over here. If you had a ball joint or something, all you need to do is have 0.5 of a millimeter distance so that they're not joined together. And then you can actually have a functional assembly as long as you design it correctly within SolidWorks. The minimum gap clearance you'd need is 0.5 of a millimeter. And something else to take into account is what's going to go in between there during the printing process is uncured powder. So you'll need a way to get that powder out. So usually I recommend having a little hole or two that you could blow air in, and then another hole so that powder can get blown out of. That just makes it a lot easier. Now this is important too. So this is kind of technical, but every printer, how they work is they go layer by layer. If you have something at a slight angle to the build table, so if the build table is 0 degrees and you go up only about 3 degrees, you would see a lot of what's called stair stepping. And stair stepping is that distance between each layer. So here would be the stair stepping on something that had not a very high degree of angle with regards to the table. Now, how to combat this is to make the part within the build table at a steeper angle. If you had something at a 45-degree angle, for example, these stair steps would be much, much thinner, and you would hardly notice them at all. So that was something we took into account when we were 3D printing this part as well. And one of the last things to take into account when 3D printing is the accuracy and the layer thickness. So the layer thickness, like on the previous slide, it's doing about 80 microns per layer. What's even higher resolution than that is its X and Y accuracy, and that's 1200 by 1200. So what that means is you have higher resolution in the X and Y. So if you needed to have something that slides together, or you needed that higher resolution, you would orientate it in the X and Y plane. Okay, with all these things in mind, that's what I suggest to Holly of how to place and how to design her part so that when we print it, she'll get a successful part. So now I'm going to pass it back to Holly.
Thank you, Luke. So here, just recapping on some of my design constraints, I knew that I needed something that was going to reach the mount and extend past the lens and be able to hold the iPad all in one part. That's another reason why he recommended that HP is because it had the build area to fit my part all in one pass. So let's take a look. After speaking with him about some of the thickness and the constraints of the printer, I realized that my part didn't go below the thickness or anything along those lines. So I was able to design it pretty easily without having to think about too much of the actual printing process. So I started off in SolidWorks, and this is really the first kind of draft that I did. Once I got to this point, as you can see, I don't even have the correct holes on this right-hand side for the hardware to come into. I decided to give Luke a call and ask him, what would you recommend? I'm at this point, I have my distances down, those basic constraints. What are some recommendations that you would have? So if I jump back over to SolidWorks, let me get over to this part. This was my first one. You can see along the bottom, I have just some material kind of cut out, a little tray to hold that iPad, a slot here to hold the glass at a 45, and then all of my distances set up. And he said that we can probably save on some material and maybe make it look a little bit nicer by removing some of the material on the iPad tray. So I took that into account, and I went into SolidWorks and I removed material and add some ribs along the bottom to add a little bit more strength to it. And then I finished cutting out the material for that bracket. We'll jump back over to SolidWorks again and let's take a look at that part. So if I rotate this around, I added some fillets to clean up some of the look for the print. We don't want any of those sharp edges in there. We can see my ribs along the bottom and then my two slots. I dropped this into an assembly to make sure that everything was going to end up working out correctly. So I have a model of an iPad, dropped it in, checked my tolerance here. I wanted a little bit of space on each edge. That way this doesn't have to snap in. It just sets nicely in that tray. And then I also added in this hardware piece. So I can see that it's going to fit on this side, moves around a little bit. If I rotate this around, I could see that this kind of turning rod here, I was able to clamp down and it was going to clear my model. For me, I thought that I was ready to go, that this was going to be good. I was 100% not even going to have to redesign. So I send it on over to Luke. Luke comes back and he says, okay, well, a lot of our tight constraints were kind of in this bracket area. So let's go ahead and just do a test part. So here's our original bracket. And then here's my test part. So there is some difference between the two. Once I got my test part, this helps to save on the material because we knew that we needed things to fit in this section. I took it up to Orinda, which is where our recording studio is, and that's where all of our hardware was at the time. And I realized that I could take this screw out of here. That wouldn't be a problem, but it also had this pin in it, as well as this metal bracket, which I actually really like the design of this because if I were to put that entire piece against the camera, it would keep it from twisting. So I decided, since I did have a revision that I could make, I was going to go back into SolidWorks and actually create this revision and implement it. Heading back into SolidWorks, I redesigned this bottom part. We'll head over to that next revision. We can rotate this around. And I still have those two slots. I added in kind of a step there for that metal plate, and then another step for that basically turning mechanism on that pin to drop back down. So added some more complexity to this in order to make it even better. That's when we start to head into our actual print. So Luke, I'm going to pass it back over to you. I emailed my part over to Luke, and now he's going to talk about his process on the printing side of it.
Yeah. So when she emailed me the SolidWorks part, I opened it in SolidWorks. To bring it into the HP software, what I first need to do is change it to what's called an STL. So file, save as, and find STL file format, and then put it in the correct file location. So I made a file for a folder for Holly. I have dropped that part in there, and then the Smart Stream software. I then just need to open up that STL. So you can see I'm browsing, and I'm going to find that STL. And then it's going to bring it in within the bounding box of what the printer can print. So this blue box is the bounding box of what can be printed. It's showing up in yellow right now because it's outside the bounding box. And the red is what side it's outside. So right now I know it's below the printing bounding box, and it's coming out, I guess, in this angle, the bottom side. So I simply rotate some things around, and I'm going to try to fit it in the printer's bounding box. And I'm going to give it a little bit of an angle too, so that we can reduce some of that stair stepping that I was talking about earlier. So the next thing I need to do is just raise it up so it's not below the printing bounding box. And there we go. Over on the right-hand side, I can see that it's 2.85 inches tall, which is not tall at all for this printer. It can print 15 inches tall. So this is only going to be about a 3-hour print. Super quick, nice and easy. I don't have to make any supports for this. I could actually add in a bunch of other parts as well. But for this example, I just had this one part. I'll just send it to the printer. And this is something else that's really nice. It's called a job report. These are made automatically. And what it is a PDF that you can print out so that if you're not the person that's doing the post-processing of this part, you can print it out, put it with the printer, and whoever is going to finish the part knows all the details about the part, the name of the part, any details of who it should be shipped to, any requirements of paint or anything that you need to put, you can put it on that piece of paper and it can travel with the, the part as well. So let's go to the next slide here. So again, I printed it on our printer in the office. And what's really nice is when it's done printing, I'm going to pull out that build unit. I'm going to bring it over to the post-processing station, and then I can recycle the powder. So with the next slide here, you can see that I'm loading that build unit into it. And now I'm actually, this picture here shows me just recycling, sucking up all the powder so that I can recycle that and use that on the next print. And there's Holly's part. So right now, 90% of the powder's off of it. The next step we need to do is just a quick sandblast, and then we'll actually be able to start using our part. That's pretty much all it takes. So you can see I brought it over to the sandblaster along with some other parts that I was post-processing. I simply sandblast it, and then I'm going to use some compressed air to blow off any of the powder from the sandblaster. And then we can actually install it, and Holly can test it. I could do some other steps if I wanted to dye it or paint it or do anything like that. But this is just a quick prototype. So this is as far as I needed to go to make sure it fits. So I'm going to pass it back to Holly. And then
Thank you,
she will
Luke.
talk about.
Perfect. So thank you. I took this part from him and I brought it up to Arinda, and that's where I actually put it into our camera. I went ahead and attached it. The bracket fit great. So doing that test print really helped out on that side. It was a snug fit on the bottom and the top. As soon as I put it on this camera, though, I did start to realize that there was going to be some flex. I added the iPad to it, and it started flexing down a little bit more than what I had really wanted it to do. I haven't even added the glass to it yet, but I was a little scared to because we all know those iPads are pretty expensive. So I didn't want to risk dropping that iPad, so I went ahead and left it off because I could quickly realize that I did have some of that flex down. And so I wanted to add some more strength to this. So I just went ahead and entered into my next revision. So here I added more material. My approach was to thicken it up, add more ribs, really constrain it a bit more. Let's take a look at that in SolidWorks. So you can see even visually right away on top, it looks different. As well as if I rotate this over, it's also different. I've added quite a few more ribs. To get a better understanding of the true difference of this, we're going to use a tool in SolidWorks called Compare Documents. It's on the Evaluate tab in the Command Manager. I can select Compare Documents. And a quick way to do this is to have the documents open that you want to compare. That way I can just select them from the pull-down menu. If you don't have them open, you can always have this browse. Just go find them. So we're going to compare my revision 2, and I would like to compare it to my revision 3. Let's see the difference that I added to this. There's different items that you are allowed to compare. There's document properties, which we have not added any. You can compare features if you would like. I know the features have changed because I just added more features to it. What I'm really interested in is the geometry. That's what I want to look at. And I don't need to align the parts because I left the origin of both of those parts in the same place. But if you want to, you can have two different parts modeled in two different spaces in SolidWorks essentially, and you can line those up and still have the opportunity to compare the documents. So I'll run my comparison, and SolidWorks right now, it's basically analyzing the faces, that structure of each model, and it's going to compare those and then give me the results. So this is nice. On the right-hand side, we can do either a volume comparison or a face comparison. And I can toggle different items on and off. Right now, I currently have the common volume toggled on. So anything that's highlighted in that green color is considered to be common volume among the two. I can turn that off if I want, maybe material to remove. We can turn that on. So I can see what material is going to be needed to be removed in order to see the other one. I always like to do the material to remove and material to add at the same time. So you can really get a nice difference of those two. If I look at the side of this one, you can see that material added. I added quite a bit of material along the bottom here to allow for a little bit more strength on that bottom. Rotating this up, you can see that I've added a material along each of these ribs as well. Now, if I really wanted to, I could pull in the material properties of this and maybe run a simulation on it and probably hollow out some of the material in this section if I wanted to really reduce that. But printing on this HP, the material isn't high cost. And since this is only one part for my particular need, I don't actually see a need to run the simulation. I'm okay with just going ahead and allowing that extra material and kind of over designing this model. Now, this was just my approach to kind of bringing this up and making it a little bit stronger. When Luke and I were discussing this, he had a completely different approach and a different idea, which I thought was pretty interesting. Luke, would you want to share that with everyone?
Yeah, so there's no perfect way to design everything. People always have different ideas, and mine was to actually go to Home Depot and buy a steel rod, and then we would actually make a hollow shaft inside it. We would 3D print it and then slide in that steel rod, and then that would be the added strength. And it would accomplish the same thing, but just two different ways of going about it.
Great. Well, thank you. So at this point, that is the rest of our presentation. Does anyone have any questions on maybe designing to print, restrictions, the HP printer? Yes, the next question is, will there be any more 3D printing webinars like this in the future? And there will be. We are going to be adding these in periodically. And so go ahead and look out for them on our website underneath the webinars. If you go to events and then webinars, they are listed, and it actually toggles between different subjects here at Hawkridge Systems. It may be on SolidWorks, 3D printing. We can dig into HP, Mark Forged, and some of our other options. All right, the next question is, are there any 3D printing open house events coming up? Actually, we do host 3D printing open houses here at Hawkridge Systems, where you're more than welcome to come into one of our digital manufacturing labs and kind of check it out more in person. This is going to be on our website. Let me go ahead and pull that up, that way you guys can see it. So if you're looking at our website and we just go to events, you can also go to the events calendar, and it will be a whole list of our events. So we have different events going on all throughout. So this is where you can also see our 3D solution spotlights. We also do a webinar Wednesdays at 11 a.m. And anything for our 3D printing stuff will be listed here. So you can see that we actually did a 3D printing open house in Santa Clara last week. Our next open house in Santa Clara, in case anyone was interested, is going to be on December 1st. All right, well, thank you everyone so much for attending. If you have questions, please feel free to reach out to us. Have a great rest of your day.